What pair of factors make up 36? All righty, so here we go. Well, I can think of 1 and 36, and I can think of 2 and 18, and I can think of 3 and 12, 4 and 9, and 6 and 6. If you want to figure out what factors are, if you don't know them by now, you can always go into your calculator and hit the number 2, the graphing. And then where it says f of x equals, you can put 36 divided by x, and then hit enter, and then hit Control T for a table. And that will give you your factors, your whole number factors of 36. Of course, you wouldn't want to use the decimal factors, but just use the whole number factors. All right, so let's get down to using the distributive property just as a review. We're going to multiply everything in the parentheses by the outside term. So 3 is the greatest common factor. That's what we kind of pulled out of this product that we're going to make here. So 3 times 5 is 15 x cubed. 3 times 6 is 18 x squared. And negative 2 is negative 6. So what we're going to do today is we're going to practice with the product already given, and you have to find the greatest common factor to be able to pull out, to separate it into 2 factors. This will help us find the area of a rectangle or a square, because that means length times width. So you're going to need 2 factors. All right, so let's take a look. It says, I have given you the GCF, which is the length, for each problem. Finish factoring to find the width by writing what will be inside of the parentheses. Distribute to check your answer. So if I've given you the greatest common factor between 5 and 10 is 5. What you're going to do to figure out what you have left over for the width is you're going to divide each term by the GCF. So these 5s cancel out, so you're going to be left with x. And then 10 divided by 5 is 2. And just like it said, you can distribute to check your answer. So 5 times x is 5x, 5 times 2 is 10. Let's look at problem 2. The GCF is 2x. Oh, so it has a variable with it now. All right, so we are going to divide by 2 and x. By 2 and x. So 6 divided by 2 is 3. The x squared minus the x gives us an x. Plus 4 divided by 2 is 2. And here, these x's cancel out. Now, if you distribute 2x times 3x is 6x squared. 2x times 2 is 4x. And we'll talk a little bit more below in the notes of how to pull out your greatest common variable factor. All right, so this one is 3x squared as your GCF. So you're going to go through and you're going to divide each term by 3x squared. And how I came up with 3? 3 is the smallest number, so that's always what you want to start with. And if 3 will go into the other 2, then you know that's your greatest common factor. It can't be any higher than your lowest number. So let's take a look here. We've got 6 divided by 3 is 2. And then we're going to subtract our exponents and get x squared. Minus 12 divided by 3 is 4. And then 3 minus 2 for your exponents is just an x. And then here your 3's will cancel out, as well as your variables. Now you can't just put 0 there, because in dividing, 3 divided by 3 isn't 0, it's 1. So now you can go and check it by distributing. So 3x squared times 2x squared gives you 6x to the 4th minus 12x cubed plus 3x squared. All right, so here it says, now factor a polynomial that only has all variables. So if we're going to factor x to the fifth plus x to the fourth plus x squared, the greatest common variable factor, here you can circle the greatest common number of x's that all terms have in common. So x to the fifth is equal to 5x, x to the fourth is equal to 4x's, and x squared. So these two x's right here is the most that is common in all three terms. You couldn't circle all 5x's here because you only have 4x's here and 2x's there. Okay, so the greatest common variable factor is the smallest exponent. Okay, so the GCF is x squared. So when we do this, what we're going to do is divide everything by x squared. And then you subtract your exponents. So 5 minus 2 is 3. And 4 minus 2 is 2. And then these cancel out to be a 1. All right, let's look at the back side. When we factor, we undo the distributive property. So it says factor 12x cubed plus 18x squared minus 9x. So what is the biggest number that is a factor of 9, 12, and 18? Well, always try this smallest number of 9. Will 9 go into 12 without being a fraction or a decimal? No, it'll go into 18, but it won't go into 12 because 9/12 would actually be reduced to 3/4. So think of other factors of 9. Well, the only other factors of 1 and 9 would be the 3. Will 3 go into 12? Yes. Will 3 go into 18? Yes. So that is your greatest common factor. That's a number. Now then, on your x's, what is the most number of x's that can come out of x cubed, x squared, and x? Remember what I said on the front side? It's the smallest amount of x's, which would just be 1. So that's your GCF, the 3 and the x. So when you factor out the GCF, you divide every term by that monomial. So you're going to put a 3x here, a 3x there, a 3x there. So your final answer will show the GCF, which is 3x, and then 12 divided by 3 is 4, 3 minus 1 is 2, and then 18 divided by 3 is 6, 2 minus 1 is 1x, minus these x's cancel out, 9 divided by 3 is 3. So the final answer is 3x times the quantity 4x squared plus 6x minus 3. So what you can do, just as a check, another check, you can use a distributive property, but also look back and make sure that none of these other terms inside the parenthesis have anything else in common other than 1. For instance, when we look at the smallest number, it's 3. The only factors of 3 are 1 and 3. 3 will go into 6, but 3 won't go into 4, so we're good. All right, so let's try these. And you might want to pause right now and just see if you can do these on your own. So we have, we're thinking of factors of 3 and 27. Well, excuse me, what I told you is to look at the smaller number. Will 3 go into 27? Yes, it will. So 3 is going to be your GCF. You don't have any variables that are common because 27 doesn't have a variable. So you're going to divide each term by 3. So this gives you x plus 9. All right, let's take a look at number 5. So we have an 8, a 4, and an 18. So always look at your smaller number right here, which is 4. Will 4 go into 8? Yes. Will 4 go into 18? No, it will not. So think of other factors of 4. So 2. Will 2 go into 8? Yes. Will 2 go into 18? Yes. So we know that 2 is going to be part of our GCF. Now, look at the smallest number of variables. It's a cubed. All right, so we're going to go through and divide each term by 2a cubed. So 8 divided by 2 is 4. Subtract your exponents, so 5 minus 3 is 2. minus, always use that same operation that's in the problem. 4 divided by 2 is 2, and then 4 minus 3 for your exponents is a, minus 18 divided by 2 is 9, and then a cubed divided by a cubed, that all cancels out. So that would be your final answer right here. 2a cubed times the quantity 4a squared minus 2a minus 9. Let's take a look at number 6. Let's see. I don't have a number that would be common other than 1. So now let's take a look at the variables. The smallest amount of e's would be e squared, and the smallest amount of f's would just be an f. So I'm going to divide each term by e squared f, e squared f. So I have left 4. Okay, 3 minus 2 e's is 1 e, and then the f's cancel out. Minus, now everything's going to cancel out in this term because e squared divided by e squared, 2 minus 2 is 0, and anything to the 0 power is 1. And then the f's cancel out to 1. So we don't put 0, and we don't just leave it blank. We have to put a 1 there because when we distribute, e squared times 4e is 4e cubed f, and e squared f times negative 1 is negative e squared f. All right, so that's the first part of the factoring process, where we take the product, which is like the area of a rectangle, and we have to find the length and the width.